Hello friends, welcome to this channel. This is G Solutions, where we find solutions for your needs. So we have here a circuit. Okay, we have a representation for our uh, sources. It can either be B sub 1 or B sub 2. We don't know if in this diagram we don't know the source, so we are asked to determine where is the source in this circuit. Okay, so to be able to solve this problem, we have to assume either B sub 1 or B sub 2 can be our source or a load. So I will be assuming here that B sub 1, okay, is the source, okay, and B sub 2 is a load. So this is my assumption, okay. And if that is the case, I will take note of the polarity. In B sub 1, the polarity is here, and in B sub 2, it is here. So if this will be my source, my current will be going out from this polarity. So this will be the direction of the current. Actually, this is total current. The same current that will pass through this impedance and also this one if this is a load. Okay, so to be able to do that, to solve for the current, we can apply the Kirchhoff's voltage law, which states that the voltages, the summation of the voltages in a loop is equals to 0. And we have to take note of the polarity. So I will make B sub 1, and this, since this is rising, it is a voltage rise, and this one, if the current will pass through this impedance, this is my assumed polarity. So this will be drop, and this one is rising. So it can be set up into an equation like this one. So B sub 1 and Z here, this is in an impedance, so that will be minus I sub T times Z, the total voltage here, and the voltage here, which is the same as this one. So this will be negative B sub 2, and this is equals to 0. So you can also make the voltage rise to negative or voltage drop to negative. Just be consistent, and it will give you the same answer. So if this is the case, I can now get my I sub T. So negative IT Z. I will put the other voltages on the right side, and the sign will change. So this will become positive B sub 2 minus B sub 1. Okay, and I want to have here an IT, a positive IT. Okay, so if that is positive, I will be dividing this B sub 2 minus B sub 1 to negative Z. So if I am going to make Z as positive, the sign of B sub 2 and negative B sub 1 will change. So this will become B sub 1 minus B sub 2 over Z. So this will be the equation. I have given value for B sub 1, which is 100 cis of 0 degree, and for B sub 2, that will be 80 cis of 20 degree all over the impedance 3 plus J5 ohms. So what we are doing is that we will change our polar form to rectangular form. So this one 100 cis of 0 degree will be changed to rectangular. So that is actually 100 plus J sub 0. And for the other one, the other term, that will also be changed. So it will be rectangular. So I'll take the positive of 80 and I'll put here negative 1. So I'll introduce an open parenthesis. So rectangular 80 and 20 degree, and it will give me 75.17 for the real part, and for the rectangular part that will be 27 plus J 27.36. It will be divided by 3 plus J5. Okay, and I will add the real part here and the imaginary part. So my real part is 175.17, but I have here a negative sign, and when you remove the parentheses, that will get subtraction. Okay, so that will be 24.83. So 100 minus 75.17, so this is 24.83. Okay, and the other one is 0 and 27.36, but because of this negative sign, it will become negative. So we'll just copy that one, 27.36. Okay, again 3 plus J5. So we transform this again to polar form. So we are now taking up the value, comma, for the polar form of the rectangular form, 24.83 minus J 27.36. Okay, and the result is 36.947 or 95 cis of 47.77 negative 47.77 degree. And also the polar form of this one, 3 plus J5. The polar form of 3 plus J5 is 5.83 cis of that will be 59 degree. And I can now divide the outside number of my polar or my polar form, which is 36.95 divided by 5.83, and it will give me 6.337 or 6.34 cis of, but since this is positive from the denominator, 59 degree, when I place that to the numerator, it will become negative. So I'll add the angle. So that is negative 47.77 minus 59. So it will give me negative 106.77 degree. So this is my I sub t, my current here. Now, knowing that the current is already already solved. So we can now proceed to the determination whether B sub 1 is a source or a load. Okay, so what will I do is that I will just get my real power here. If the result is positive, then my assumption is correct, and because my current is going out to this polarity. But if I get a negative result, it means that this is incorrect. So it means this will be a load if it is incorrect. But if I get positive, so therefore this assumption is correct. So this is a source. So I'll have to get my power at B sub 1. So to get the power at B sub 1, you know already the current and the voltage. So the voltage is 100, cis of 0 degree, and the current is IT, which is 6.34 cis of, but since our formula in getting the power, actually this should be an apparent power, so instead of using P, I'll write here S. Okay, so the formula is SB and the conjugate of your current. So the current here is 6.34 cis of negative 106.77. So the conjugate of this current is positive 6.34 positive 106.77 degree. So if you're going to multiply, you multiply 106.34 and you add the angle 106.77 plus 0, so it will give you 106.77 degree. Okay, so if you are going to multiply, this one is 634 cis of 106.77 degree, and you transform this to rectangular, so that will be rectangular 634. The angle is 106.77. Okay, so the rectangular is negative 182.93. Okay, plus this is J 607.04. Okay, so this is my power in this source. So therefore this is my real power and this is my reactive power. So my real power here is negative, so it means that the assumption of this one is incorrect. So therefore B sub 1 is not a source, it is a load. B sub 1 is a load. Okay, so my assumption is incorrect. So I can now give you an answer that my source will be B sub 2. Okay, since that B sub 1 is a load, therefore B sub 2 is a source. Now for further explanation or proof that this really is the source and this one is the load, I will get also the power here, so that will be SB2. So what is my voltage here? That is 80 cis of 20 degree multiplied by the current. So I will get now the conjugate of the current, so that will be 6.34 cis of positive 106.77. And if I am going to multiply this one, so I have 80 times what's this 600 6.6 6.34 times 6.34, sorry, 34 equals 507.2. So this is 507.2, and I will add the angle, so that is 20 plus 106.77, and it will give me 126.77 degree. Now I will get the rectangular form of this one. So rectangular form, shift rectangular, 507.2 comma 126.77. Okay, so that is negative 303.61. Okay, plus the other part, which is plus J 406.29. Okay, so again, this is my real power and this is my reactive power. So you will notice that your real power also has negative sign, same as this one. So therefore, if the current is going here, it is incorrect also. So therefore, your B sub 2 is a source. Okay, so my answer now is that B sub 2 is my source. Okay, so this is how you solve this circuit problem. I hope I contributed added learning to your learning desire. Okay, thank you so much for watching this video.